All attendees, thank you for joining today. I think we're going to get started here pretty quickly. A little bit of housekeeping before we get into the presentation. On your control panel bar from GoToWebinar, there is a section in the middle called questions. If you guys have any questions during the presentation, please feel free to write them down, and we will either attend to them if we have the time in the presentation. If not, we'll handle all Q&A at the end of the presentation. But feel free to voice your questions, and we will definitely get to them depending on timing and the nature of the questions themselves. So thank you very much for joining today and giving us some time. In our association with Intelligent Concrete, who is our research and development partner, Surface Tech is hosting this series of webinars on alternative supplemental cementitious material, ASTM C1709 segment, in terms of a category that has some very important resonance in the concrete industry and gaining more and more attention as we are trying to fight raw material issues and fly ash issues that are plaguing the concrete industry. As a bit of an introduction, today we will have the first part of the series presented by Dr. John Belkowitz. John is the R&D director for Intelligent Concrete. He and his wife Whitney own a certified and highly respected research and lab facility in Elbert, Colorado. And they are very, very highly recommended and respected with regard to their bent on innovation in the concrete space. John is a teacher, a speaker, a card-carrying ACI committee chief head, chair. We'll probably be working very close with the current chair on this ASTM C1709 category of ASCM. And we are very pleased to have him today bring an educational series to the community on exactly what is alternative supplementary cementitious material and what is its application in the industry today. John will go into a lot of detail with regard to that, but I think this is a extremely important and timely series for us to get a much better grip on with regard to this category in concrete. Without any further ado, I'll turn it over to Dr. John Belkowitz.
Thanks, Steve. Appreciate that intro. And Steve, I got to correct you. Surface Tech has done a lot more than just hosting this program. Surface Tech has really been what I would like to call the champions of this ASCM movement. And we are going to be spending a little bit more time looking at what Surface Tech has done in segments 2 and 3, but we are going to mention what Surface Tech is doing, has done, and has brought to the industry. So, Steve, thank you for making this opportunity possible, you and Surface Tech. Okay, so first slide. Welcome, ladies and gentlemen. My name is Dr. John Belkowitz, and it's my pleasure to talk to you today. What we're going to be going over today is what I like to call the magical world of concrete. Specifically, we're going to be diving into a webinar series on alternative supplementary cementitious materials. Now, the impetus for this presentation, besides that magical world of concrete, is that there's not a lot of information on this out there in the industry, and we, as stewards, need to educate the industry. Next slide, please. So before diving into the meat of this presentation, like I said, my name is Dr. John Belkowitz. I have a PhD in mechanical engineering with a specialty in nanotechnology of concrete. I've spent the last 20 plus years in the concrete industry trying to perfect, understand, and really just get my hands into this simple yet complex material. My first experiences were afforded to me by the United States Air Force, where I was part of a civil engineering squadron where our job was to provide, prepare, and sustain bases as the platform for the projection of aerospace equipment around the operational continuum. And through that, I was able to go all over the world, make and break concrete with all types of people, cultures, and materials and equipment, and really became that concrete enthusiast. And I have a bunch of degrees from a bunch of schools, worked for a bunch of companies, and with my wonderful, beautiful wife, we created Intelligent Concrete a little bit over a decade ago, where we could pool all that knowledge that we have about some of these awesome technologies that sometimes get put on the back shelf of a university basement or even of a private industry. And then what it takes to do that technical transfer all the way from the bookcrete to the labcrete to the realcrete, and that's what we specialize in. Next slide, please. So the impetus of this presentation, the overview, what I want you to walk away from is these 4 key topics. First one is why have ASCMs been created? There's a real reason, and depending where you're at in the country, that reason might not relate to you. You might have, that perfect Roman concrete area, not only just the perfect materials, but the perfect climate zone. I mean, nobody talks about it, but that Roman concrete, one of the reasons why it lasted so long was not only the materials, but also the fact that you're in Rome, and it's a beautiful place to be, and you only have an earthquake once every few hundred years, maybe 1,000 years. So we have a real reason to create these ASCMs. But then the question is, what is the governing, evaluation, governing guideline that tells the end user how good this stuff is compared to something else? And we're going to go over that today in our second point, ASTM C1709, and really break that down as to why that is the practical ASTM, as it was called by some of its authors. The third thing is the status of industry adoption. And this is something that Steve and I have had a lot of conversations about. And we wanted to be transparent about this because we are seeing some obstacles, and all of it is based on the edification that the industry really doesn't even know that these things exist on a scaled level, and that there are guidelines and evaluations that are published to really govern the quality management system. It's not like getting a fly ash today where you don't know what the quality is. There is some great amount of information that has to go behind these ASCMs to bring them to market. And then finally, I wanted to hang my hat on a very specific hook. Why ASCMs have merit that benefit the concrete and construction industry. And it's something that we see here in the concrete industry out in the Western U.S. business unit, from Colorado all the way over to the West Coast. And it's even going eastwards, but the problem has become more prevalent here, and that's alkali silica reactivity. And I cannot wait to go into that. Next slide, please. So we're going to focus on why ASCMs have been created. Next slide. I'd like to give you a short definition, but I don't want to go too much into the definition. Oops, thanks. Good job. I want to go into a short definition and then dive into this ongoing concrete durability issue that really doesn't have a solution outside of what I believe is ASCMs and how these ASCMs are going to impact the concrete industry moving forward. So let's just dive into it. Next slide. ASCMs, and this is a nice bird's eye view of Juno XP. A short definition is a dry material that acts to similar to, but does not meet the chemical and physical requirements as supplementary cementitious materials. Now, again, that doesn't necessarily mean it's a bad thing, the fact that it doesn't meet the chemical and physical requirements. It just means that it doesn't fit the current standards that we have available to define the guidelines and the specifications for these more matured ASCMs. And we're going to talk about that. And the harsh reality is, especially out here in the Western US business unit, we just haven't seen the volumes, nor have we seen the qualities that we're used to meet the demand of the concrete industry. Next slide. And that harsh reality is we have an ongoing issue with concrete durability. We have over 600,000 concrete bridges in our national inventory. And the last time we checked, we have a $48 billion a year industry. That being said, there's an extra $8.3 billion put into concrete every year to deal with the maintenance associated with physical and chemical attack. Now, I'm not saying that concrete is broken. Far be it from me to criticize a material that has built civilizations throughout time. But I'm trying to say in the politest way as possible, we need to enhance our durability. And you don't have to take my word for it. Wait another 5 years, and this issue that we have, that we've seen since 2009 and back, it's going to punch us in the face if we don't start looking at other technologies besides the ones that we've been using for the last 3 decades plus. So we need to enhance that durability. Next slide. It's not only for this type of marine type failure, but we also see it not in these higher end structures, but in lower end structures. I mean, we also work, I work in the residential industry as well as the marine structures. And in the residential industry, this is common, that we see that concrete falling apart, within that first season. We have folks work for us who are in a subdivision and there's mag chloride all over the place, and that concrete is falling apart within the first season. And this is what 1 season on the left looks like, and then 2 seasons on the right looks like. And that's just something that we as an industry have been willing to accept, because we all know that either we don't have the high quality materials, or we just don't have enough of even low quality materials. And I'm talking about for us here in the Midwest, Class F fly ash. Next slide, please. And this is something that we haven't talked about, this durability problem. And oftentimes when I bring it up at ACI, ASTM, I get people who roll their eyes at me. And normally they're from Chicago or New Jersey or Pennsylvania, where they're still burning coal. And they say, John, we don't have a problem. And of course you don't have a problem. I'm not talking about you guys. I'm talking about the folks out here who do not see the Class F fly ash, where they need 20 to 35%. What you're looking at right now, here's a portion of the dam. And that is, by definition, an ASR crack, something that looks like the Isle of Man flag, 120 degrees. This is literally a textbook definition of an ASR crack. And right next to that is a human hand. So that is your scale right there on the type of ASR damage that we have to deal with, not only on a local level, but also on a national level. Next slide, please. And it's not even limited to our dams, to our residential. This is one of the airports out here in Colorado. Now, granted, this is ASR plus decracking plus mag chloride attack, but the harsh reality is we're beating up our concrete more. We've got more traffic. We've got more transportation loads. We've got higher alkali cements. We have more reactive aggregates, and we want more out of our concrete. We want 28-day strengths and 24 hours. It should come as no surprise to us that if we burn the candle at both ends, we're going to start seeing things like this. And again, this is not just on a residential level. It's not on a local government level. It's not just on a international airport level that we see right now in front of us. Next slide, please. But this is also on a federal level for dams, locks, spillways, dams that we rely on every day. I don't know if y'all know this, but in New Braunfels, Texas, I think it was last month, we had a dam fail out there. And I think it was Canyon Lake the dam failed, and we have friends who live on that lake. We have over 312 concrete dammed facilities in the Western US. The American Society of Civil Engineers gave us a D+ for our civil infrastructure rating. We need an alternative to what we have relied on all the way from college, or if we were working out in the field, if we're in a ready mix plant. But what we relied on for Class F fly ash, next slide, please, we can't hang our hat on that anymore. And if I'm the first person to tell you this, I apologize for being the bearer of bad news, but the great thing is there is a solution to this problem. And I want to be the first person to define this problem. An alternative to what? This little picture that we have here in the background, I'm about to blow it up. But that's a real product. Both of those are real products that we get here in Colorado. The product on the left monopolizes water, monopolizes high-range water reducer or admixtures, kills our fresh properties, kills our strength, requires us to put more water in to compensate for slump. Our airs are hard to generate, and we don't get the durability that we used to rely on. Now, the ash on the right, next slide, please, is the ash that I grew up on as a kid. We used to call it the poor man's water reducer, and we used to get it for $20 to $40 a ton. Now, we just don't get that ash anymore. Thanks, Steve. We just don't get that ash anymore. We can't rely on that ash anymore. And it's not even for the immediate fresh properties, but it's also for the long-term issues that we have to deal with, like alkali silica reactivity, like de-icing salts, de-icing brines, de-cracking, bad aggregate. So what can we rely on if we can't rely on Class F fly ash? Now, I'm not saying that we need to throw Class F fly ash away, but next slide, please. Using ASCMs, if the ASCM is good enough, you can use it in conjunction with your fly ash. Now, let's for a second, and I don't want to ignore surface tech, but if we look at holistically what an ASCM, an alternative supplementary cementitious material, should do, and again, Juno XP does all of this, but holistically, we need to have a cement reduction for greener concrete. CNN has done a wonderful job telling the world how horrible concrete is and how cement is the devil. Now, I don't know of a better material that can build civilizations throughout time but concrete. It is the most popular. It is the most versatile. And when it comes to building the Kosciuszko Bridge or the Verrazano Narrows Bridge, you couldn't really do that with lumber. You had to do that with concrete and with steel. So by using an ASCM, something like Juno XP, we're supposed to be able to reduce our total cementitious and not sacrifice those fresh and hardened properties. And by doing that, by reducing our cementitious, not only our cement, but our supplementary cementitious materials, we're doing that because we're increasing the efficiency. We don't have to produce as much cement to replace the extra cement that we would have had to use if we didn't use those ASCMs. And what we see with that is a cost maintenance reduction. Now, there are times that you're going to have to add those ASCMs and not do a % replacement because you need that durability aspect. You already leaned up your mix. You know, it's gone through the optimization process, and now you need something to either boost the toughness, boost the durability, or boost any type of the strength. But what it comes down to is the ASCM that is scalable, the ASCM that meets the 1709 and the needs of everybody on this phone call needs to be gray concrete coming down the chute, closing it up on a Friday afternoon at 4:30 with a beautiful finish and heading home. It can't be anything else like that. And right now, the unfortunate reality, Steve, if you can go back one slide, the unfortunate reality, and if you haven't been on a job site lately, you need to go. The stuff on the left, that fly ash, it's not making concrete that's easy to place. It's making concrete that's difficult to keep the fresh properties consistent over a long period of time to meet the recurring work program. And that's just what we have to deal with nowadays. Next slide, sir. One more. Okay, so I keep talking about this ASTM C1709. Oh, back one more. And this is the roadmap that I'm going to take. I want to cover it. I am going to use segment 2 and segment 3 to show you the practical applications, but I want to use the ASTM to define ASCMs and then go into the different stages, because I want to show you the quality control process that you need if you want to scale this type of material up. It's not an easy thing to create an ASCM. And then I want to go into a comparison, or what you as an engineer or even a contractor need to know about, and then do a comparison between what we're used to versus the 1709. Next slide, please. All right, so 1709 is a fantastic ASTM, and it even has a Canadian version. I believe it's CSA 3004 ER.71. I could double check that, but there is a Canadian version. And it really, the first page and the second page on the right-hand side spells it out beautifully for you. If you had any questions on how to use this data set and how to interpret it, if you're in one of those places where you're running out of your Class F fly ashes and you can't get your silica fumes, your slags, or your metakaolin. So 1709 is published. It has the 2018 version, and it is available on the ASTM website. And what I'd like to do, next slide, is go over that definition, and I pulled it right out of ASTM C1709, and I wanted to read it for you. As the technical and economic benefits of SCM have been recognized, and as sustainability and environmental awareness resulted in the need to develop new materials and new ways to use materials not previously utilized, new sources of potential SCMs are being proposed for use in concrete as ASCM. Now, if there wasn't a better way to talk about our need as a larger industry, we have an environmental need to reduce CO2 emissions through the production of cement by reducing the amount of cement that's being used. And if you're from the cement industry, I'm not going to apologize for anything that I just said, because y'all know what I'm talking about. It is a reality that we put out somewhere between 3 to 5% of the world's CO2 emissions. We have the technology to increase the efficiency. I personally never want to go away from Portland cement. I love this stuff. It's absolutely amazing. But that being said, we need to increase the efficiency of it, because we are going to eventually run out of raw materials. And I like this earth, and I like the environment that we have, and we need to, for our kids' sake, do something better to make sure we have concrete that is stronger, lasts longer, and it's saving the world too. So this one statement within ASTMC 1709, I think, really epitomizes the ultimate approach. And as the engineers, sometimes the ready mix providers, the contractors, their hands are being held by what you as the engineer are tasked to do. And as that responsible, qualified person for the job site, it's your duty to look at new and emerging technologies. Hey, I teach at university. I've got to pull these definitions out of the ACIs, out of the textbooks, out of the PCAs. I wear the order of the engineer, because my job is to bring new and emerging technologies out there in the most responsible way to make this a better concrete world. And that's, I'm proud of everybody who got on this phone, who got on this phone call, who got on this webinar. And I'm excited for what we're going to see here in the future. And if you have any questions about how to use this to save the world with all the concrete in it, I am more than happy to answer any of those questions. Next slide. So if you were curious about what an ASCM looks like, this is Juno XP. And I mean, it's my favorite ASCM. I'm allowed to have a favorite. It's my favorite ASCM because it meets the demand of the industry and it's scalable. The other thing is, I have not yet seen a lot of ASCMs out there that are designed to meet the demand like Juno XP. And truth be told, I have not seen a lot of ASCMs out there. Some are coming to the industry, but in my opinion, they are not as scalable and ready to hit the ground running like Juno XP. Now, if you notice it on your screen, it's somewhere between a fineness of cement and a coarseness of a masonry sand, an ASTMC 1044 sand. And we've done that on purpose. There's two very specific technologies, and I want to talk about it in a mechanical and chemical way. And what I mean by that is, when I first came into the industry, we started using multiple coarse and fine aggregates in our self-consolidating concrete to make the concrete robust. And part of what we're doing here with the intellectual property behind Juno XP is using it in a mechanical, macroscopic way to fill up some of the voids in the granular skeleton to effectively enhance what the paste is doing for the concrete. So we're effectively manipulating that granular skeleton to get a higher efficiency out of that paste. And what we ultimately see out of this is, well, it manifests in what seems like a ability to reduce water in our concrete while still maintaining those fresh properties. Next slide, please. Now, if we look at it on a microscopic level, Juno XP, its two active ingredients, and of course I can't tell you those, or Black Hawk helicopter will come in and but the proprietary technology behind Juno XP focuses on two components. One, your traditional type of pozzolanic material that consumes calcium hydroxide to develop more of the backbone of concrete strength, the calcium silicate hydrate. The other piece of that is a mineral component that has the same chemical makeup as the superhero of concrete strength, and it has a toughness greater than para-aramid fibers. So what we're ultimately seeing is somewhat of a molecular connection at the interfacial zone and an absorption of the catastrophic forces that would cause, premature failure. And it can manifest in tensile or shear loads, and whether that's from actually putting loads on it from higher transportation loads or from the expansion of ASR or alkali silica reactivity at the interface of the aggregate. Next slide, please. And what we're used to is this. We're used to ASTM C618, at least I'm used to it out here in the Western US and going over to the East as well. But this is the specification that we have used traditionally for the last few decades for specifying that coal ash or natural pozzolan for use in concrete. And it is very specific, but it's also very limited on what we can introduce into the back of the truck or even into the engineering specifications. And while these materials, this coal combustion residue and the calcined natural pozzolans are great, there are some other great materials that can be used to make concrete stronger and last longer. And we should not be limited by what we are comfortable with. At a certain point, many decades ago, we were not comfortable with silica fume. Many, many decades ago, back in the 60s and 70s, Per Finestål, God rest his soul, brought silica fume to the world. And nobody embraced the idea now back then. Now, it's commonplace to use silica fume if you can get it at a reasonable price. So if we can't get silica fume at a reasonable price and we can't use these ASTMs like 618 that we've been used to, the next place to move is this ASTM C1709. Next slide, please. Now, I've been very fortunate enough to be in the presence of a lot of these folks, these absolute brilliant minds of the concrete industry who put together these ASTMs for the industry. And when I spoke to one of the authors, he called it the practical ASTM. And as much as I love that, I wanted to call it something different. And the way I see it is, the way it's a practical ASTM is because 1709 truly connects the bookcrete to the labcrete. And sometimes I say realcrete, but it's more to the fieldcrete, because the lab and the field are two totally different monsters. And while I've seen some amazing technologies in the field, it's rare that you have an ASTM that not only connects the lab, but it uses tests, it uses methods to showcase what that technology can do in the field. Next slide, please. So I don't want to go into much depth about 1709, but I did want to break down the 5 different stages. And this 5 sets of stages, I remember talking to somebody weeks ago about Class F fly ash and how the quality of the Class F fly ash is reduced significantly. And something I posted on LinkedIn, and somebody wrote back to me, where in 618 does it talk about quality control? And for the life of me, I could not argue it. But ASTM-C 1709 does talk about quality on many different levels. So throughout the 1709, you have to go through these 5 different stages where you basically go from microscopic, looking at the physical and chemical breakdown of the material. You're characterizing the material, but you're also going through the mortar mixes, the ASTM C109s, the strength activity index, the water demand test, and you're going all the way up through comparing it to a 618 or a 98, whichever one you choose. And then you go through the 1-year lab test, and then you still have to go to the field. Next slide, please. It is rare, even if you look at ASTM-C 494, it is rare that you see an ASTM, an evaluation process, force you to not only do that long-term test in the field, the quality management for, I think it was like 6 to 10 months, but you also have to go out to the field for 3 different job sites and monitor each job site for 1 year. Now, come on. Like, if you want to talk about the the quality control and really understanding the back of the soup can, 1709 to me is the realest, is the truest, the most practical ASTM out there. Because if you ever had a concern about what the material could do to concrete, in my opinion, the 1709, it might not answer it for your specific mix, but it will give you a great holistic and bird's eye view. Next slide, please. I get a little excited about this stuff. And the reason why I get excited is because I've seen the industry change. I've been in Colorado since '99, so it's now 20 years, and I fell in love with this place. I fell in love with the Western US. And I've seen how drastically it has changed based on the absence of fly ash. And something like ASTM C1709 that makes sure that that ASCM goes through, you know, everything. These are just some of the tests that you have to do. There is a laundry list of methods that you have to explore the ASCM to ensure that it's going to do the job that the SCMs that we used to rely on did decades ago. Next slide. And when I look at the 1709, I find it easy and tough to compare it to the 618, the 989, and the 1240. Now, 1709 is an alternative supplementary cementitious material. It's a very broad and open category that allows for a lot of different materials, whether they be hydraulic, pozzolanic, or mineral, or a combination of all the above. 618 specifically covers coal ash, raw or calcined naturated pozzolans. 989 specifically covers slag cement, and 1240 silica fume. And of course, we have all the ASHTOs and the ENs and the CSAs equivalents of these as well. And I'm still looking for the equivalent in the EN as well as other standards for the 1709. But for the CSA, it's that CSA 3004. And as it stands, the 618, the 989, the 1240 are designed for those materials. So things like you have to have a minimum of 70% silica-based material, and that can include some alumina and I believe some iron. Then there's also, you can't have more than 34% retained on a number 325 sieve. You can only have, you know, a maximum of 5% alkalis, and if you do have more, so on and so on and so forth. The 1709 is a little bit more open than that, and what I believe it does is it recognizes that putting a prescription on a supplementary material does not really give us the opportunity to see the benefits of the different materials that are out there. And, you know, there are, if you take that holistic view outside of Juno XP, you know, you've had these talks of pet coke ash, rice husk ash, you know, corn husk ash on a university level for many, many decades, but we haven't seen that scalability, and that's what Juno XP brings. Bringing that quality of a supplementary cementitious material to the concrete industry to meet the demands that Class F fly ash can't meet anymore. And if you're a Class F fly ash distributor, it's just the reality that you've seen for the last few years, especially out here, that it's either the blip in the radar is real and we're not getting the volumes, or the volumes that we're getting, they're not of the same quality. Next slide, please. So with that being said, if I'm talking about a problem that everybody knows about, how come we need to educate the industry? Why isn't the industry going after these SCMs on their own? And again, I do not mind, you know, speaking the truth. It's just, I hope that everybody on this phone recognizes the reality of the industry. And part of that is, next slide, please, we are a risk-averse industry, and we are very slow to adopt new technologies. And sometimes folks have a very negative and pessimistic way of saying it, that, hey, the concrete industry and the civil engineers would be more than happy copying and pasting, clipping coupons, than trying something new. And yeah, maybe for some it's like that. But the truth is, as engineers, as contractors, as ready mix providers, anytime we make a decision, that decision, we own that for decades. The engineer owns it because they have the liability on their professional engineering stamp. The contractor owns it because they built the structure, and the ready mix provider, who's also considered a contractor, owns the material that they make. And it's all specified in ACI 132, I think it's R-12. But we are a risk-averse industry for good reason, but it doesn't mean it's right. And mark my words, if you're not making the decision today to go to an ASCM, you're gonna have to do it next year, the next 2 years. If there's anybody from Nevada, New Mexico, Arizona, Texas, you should be emailing Surface Tech right now, because you have this problem that I'm talking about. For Colorado, we're not seeing the absolute vanishing of our fly ash often enough for it to become a real fear, but it's happening. And it's not like our aggregate is innocuous. Our aggregate in some places is unpredictable when it comes to ASR. And the harsh reality is that the DOT engineers, the one who kind of like set the tones, especially for the bigger jobs, maybe not the smaller residential jobs, but the DOTs are not aware of this. And I'm not faulting y'all. Y'all have a busy schedule. And that's why we're doing this webinar, because we want to educate you holistically what ASTMs are out there, what has already been proven in the industry, not just in the lab, but also in the field, because we know there's the fear of moving forward. We do these things over and over and over again because we know they work for a long period of time, or at least a period of time. And when we need to replace them, they have a built-in obsolescence. So it keeps the economy going. But there is too much of a concrete waste problem. There's too much of a cement CO2 issue for us to ignore this any longer. I had a buddy of mine up in Steamboat. He said, hey man, and this is a buddy from the military, and he said, hey man, I've got 200 yards going out. I need a letter. Can you write it up? I said, dude, whatever you need. He goes, cool, 200 yards going out. It was a Friday afternoon at 4:30 when he called me. Can you write me a letter? I can't get an ounce of fly ash, and I'm doing this job on Monday. I said, what letter do you need? He said, I need a letter to say I don't need to use fly ash, 20% fly ash in an ASR mix. And I said, heck no, man. I am not giving up the company I love to write you a letter. But this is what people are doing, and they're moving forward without the fly ash. So we're making concrete because we need to meet the demand of this construction. Next slide, please. So I've been painting this horror story, and I'm going to do it one more time because I want to show you that there is a real problem that we need to address. And the things that we were doing 10, 20, 30 years ago, they're not working anymore. And if they are working for you, if you're in Chicago and you're right near a fly ash plant, I give you 10 more years at the most. We cannot undo this renewable energy movement that we started in 1978. I don't care what president or political party you support. We're losing out on the sands that we relied on, the sands that were non-reactive, that were easy, that had low absorptions, and we're losing out on the fly ashes, and we just have more problems, and we still have to meet the demand of an ever-growing 7 billion population. If there's anybody on the phone from New Zealand and Australia and Asia and Hong Kong, you know what I'm talking about. So why do these ASCMs have merits? Next slide, please. And to me, the ASCMs are the solution. The ASCMs are the knight in shining armors to the next slide. This is an in-service water reclamation project. This is not a horror movie. This is not CGI, and this is non-filters. How do the kids say it nowadays? No filters or non-filter, whatever it's called. This is a true life photo, and we're supposed to be okay with this. Now, granted, this is the extreme, but this is the harsh reality that I keep referring to. And this is not a surprise. That's the worst part about it. Next slide, please. So this is a place in the United States in the Western US Business Unit. And this is a paper written by the Denver Federal Center in Denver, Colorado, the US Bureau of Reclamation, who is employed by the US Department of Interior. And back in 2009, 2009, they called this out. They said that, hey, we're going to have this huge ASR apocalypse, and it's coming out in the horizon. And it's not just that we're going to have it, but we got 3 reasons why it's going to happen. And we've known about it, but we haven't really made the move yet. And I understand you have a fear of getting TS, a fear of trying something new. It's time to get over that. We're already behind the power curve. Next slide, please. Wonderful paper, by the way. So, and it's free online. Fantastic paper. All the conclusions are right in the front. So let's go into some ASTMC 1567, a great test. We're also doing the 1293, but I like this because it really shows that rapid growth over time. And with the Juno XP, these are just some of the tests that Surface Tech had us run to elucidate or illustrate the benefits that Juno XP could bring through this ASTMC 1709 evaluation. Next slide, please. So this is ASTMC 1567 and 1260. We did a lot more than what was required. We actually tripled up on our references and we doubled up on our Juno XP dosages because this is a major problem and we need a major solution here in the Western US. And we used a very reactive aggregate, this Kremli aggregate, and used 2 different types of F ashes that you've already seen a number of times. That fly ash on the left, that darker fly ash, was fly ash number 2, and the pretty beige fly ash, that's reference number 1, and that is the darker blue color. And as you can see, when we're using straight cement at 28 days, we're exceeding, oops, that 0.1% should be a little higher, apologize. But at 28 days, even at 14 days, we are exceeding that 0.1% limitation that we have for most of our DOTs and our FAAs. And even when we use 20% of that bad class F fly ash, we're not doing anything good for the concrete. Even at 14 days, we're seeing that expansion well above that 0.1%. It's almost if we shouldn't use that class F fly ash. Now, of course, when we're using a great class F fly ash, we're seeing that reduction at 14 days. And, you know, it sucks, but even with a really good fly ash, we need newer technologies to get us below that 0.1% expansion at 28 days. And while we didn't do the combination here, we believe using Juno XP in combination with a good or even mediocre class F fly ash, we've seen the results will get you that 0.1% expansion below the 14 and 28 days. And if you don't believe it, look at the results that we got here at 2.5% and 5%. So we have more Portland cement in both of these mixes. The Juno XP enhanced mixes, the ASCM enhanced mixes are almost acting like the 20% good class F fly ash mix. Next slide, please. And I wanted to zoom in on it. And what I did is I reordered it. So I took the 28-day average and I put it in order from most expansive to least expansive. And I used that last one as my reference for all of them. So if we compared that best reference, that 20% fly ash that we just don't get anymore, to the Juno XP, we're only seeing a 9 and a 10% increase in the expansion. And what we've seen when we combine the reference 1 at 20% with a little bit of Juno XP, we're seeing it enhance that reference 1 to make it an even better class F fly ash and solution for ASR. But that reference to that crappy fly ash, it increased, the expansion was 41% over the good one. And of course, the Portland cement, which none of us are surprised at, is a whopping 53% over that reference 1, that fly ash that we were used to when I was a kid. Next slide, please. So with all that being said, what is the next step in the industry? And the answer is education and adoption. And that's where I want to finish this presentation. You know, ASR is only one major problem that we have ongoing in the concrete industry. I mean, even if you look at the PCA stipulates that our biggest problem for premature concrete failure and premature concrete failure is, or tear out, is steel corrosion of reinforced concrete. Now we're talking bridges, decks, high-rise structures. These are real structures that, affect people's lives every day. And we have few viable solutions. Class F fly ashes are gone or are leaving us. Our lithiums that we used to rely on and couldn't rely on them all the time, but used to rely on them to a degree, they went to a different industry. You heard the story that I gave you about that case study, that absence of Class F fly ash in Steamboat, Colorado. And it's not the only place. We were at TRB and we learned that 13 states out of the 49 continental US will not have or do not have Class F fly ash. And by, I believe it was 2021, 16 more were being added to that list for a total of 29 states that won't have Class F fly ash. Those aren't my words. What we have shown with ASCMs that they do show success not only in the bookcrete level, the labcrete level, but the field and realcrete level. We've shown the commercial success over and over and over again. Now, my job and everybody's job at Surface Tech is communicate to the professional engineers, the construction managers. We want to educate you and the other industries to save the world with all the concrete in it. And I'm not trying to sound hokey. It's not the folks on CNN who are going to change the world. It's us. It's us working together as a team, collectively. And I hate to say it, but we need some transparency in the industry. We need to see those mixes. And again, if I'm the first one to tell you, a lot of your mixes are the same. And if this is a surprise, I apologize, but changing up the cement a little bit here and there, you can use ACI 211 to design some beautiful mixes, but a little bit of transparency. And these ASCMs, the ASTM is forcing us to be transparent. And with these results that we have, both lab, field, and the commercial industry, we can answer a lot of your questions to help concrete be stronger and last longer. Next slide, please. So segment 2 is that proof in the pudding. I want to share the material properties, and then I want to go over the ASCM employment methods. And it's going to be a calculator necessary segment. So I need you to have a calculator, I need you to have a pen and a pad, and what we're going to do is jump into concrete mix design. And yes, we are jumping into concrete mix design. I'm going to show you how we use Juno XP as a lever system, especially if you're in one of those states where you're manufacturing sand or you've got aggregate that's above 3% absorption. So we're going to look at residential concrete, self-consolidating concrete, ultra high performance concrete, and I think we might even throw in a cement stabilized soil, because those are always fun. I love those. Okay, next slide, please. If you have any questions or comments, we're ready to take them. But I want to remind you of why everybody is on this phone and why we're doing this. You know, when I became an engineer, I wanted to be a concrete superhero. And I know my upbringing in the industry is different than most. I knew I wanted to get into concrete from, I think it was 13 or 14 years old. And I saw my passion for it once I got into the military and I was allowed to make and break concrete on a very large scale. One of my things that I've seen that my wonderful boss and wife pointed out is that our biggest problem in the industry is that we're solving today's problems with yesterday's technologies. And it's not our fault. We started doing that at the college level, especially if you're the engineer on the phone. You know, you barely have more than one lecture on concrete mix design. Whether you use the NAWI textbook for your reinforced concrete or the other ones, there's about a chapter or half a chapter on concrete mix design. But as a student, you didn't spend a lot of time learning about new and emerging technologies and how to do more than just using the concrete mix design of the person before you, of your predecessor. And there are tools and methods and YouTube videos of some brilliant people and how they're going over this new and emerging technologies or just doing concrete mix design. So with that, I would love to open up the floor for any questions at this time.
For questions, you guys can type in on the question box, kind of as you are thinking about questions and why. John's covered a lot of material today and did a great job. You will get the attendees will all get a recording of today's session as well as a copy of that presentation. So if you have questions from that, you can always reach back out from that point. So I'll give you a few minutes here to load up any questions if you have it. John, there was one
So one of the questions that we get is,
there was one question.
sorry, go ahead.
I think El Cahil's questions were answered as you went through your presentation, but there was one at the end. You wanted to know if ASCMs provide a high rate of pozzolanic reaction.
So thank you for the question, El Khalil. They do field a higher rate of pozzolanic reaction, but it's not going to be as high as silica fume. And the reason why we sacrifice that certain rate of reaction is for that mineral component that will increase the toughness. And at certain dosages of using silica fume, when you get above your 7.5%, you start seeing not a toughened hydrated cement matrix, but a more brittle, something that is more prone to catastrophic and brittle failure. With the Juno XP, we see the opposite. We might not see that instantaneous pozzolanic reaction, but that mineral component that I spoke about earlier, it's going to increase the tensile and shear capacity of the mix in lieu of reducing the tensile and shear capacity like we see with the silica fume or microsilica.
Good job. Give me a couple more minutes here and 5.2 attendees.
Now, listen, I'm not saying SCMs are a bad thing. Silica fume, especially, it's a great material, but the harsh reality with that one is that it does make it more brittle. So I'm not saying it's bad. It could actually be used in conjunction with Juno XP. It just happens to be that Juno XP is a little bit better, especially for making a more resilient concrete for long-term and short-term durability issues.
There'll also be a cert that will be issued as part of this webinar series. That was another question. Okay. Okay, team. Really appreciate your time. There's no other questions. Please, if you do have them, pitch them to us as a response to the email that you'll get as a wrap up to this session, and look for the invite for session 2 and session 3. They'll be coming out here in the next few weeks. Appreciate your time. John, excellent presentation.
Thank you, sir. Y'all have a nice one.